kind of moving into this analytical geometry part of pre-calc. So we get to talk about conic sections, right? So, basically, if you look there on page 395, I am recording this for people, so I'm going to have to put a picture up, but I want you guys to have it there too. What is happening? There we go. All right, so we have a few pictures here. Okay, so we have this one. So basically, we're thinking about cones, right? And the way that they are kind of coming up with these cones is like they're taking a slanted line and like spinning it around, right? And like twisting it. So it makes two of these cone shapes. Okay. Vertex point is obviously where the top of the cone happens. Okay, that generating curve they're talking about is where it's like spun in a circle. Axis goes straight down the middle, things like that, right? But for conic sections, we're basically talking about all the different ways we can slice through this thing and the shapes that it makes. Okay, so like the first one, a parabola. Like they take this blue piece and like slice through that side of the cone, right? Just one part of it. And that shape that's formed right here, I'll chase it, right, would be a parabola, right? So, graph of a quadratic equation that we've dealt with before, okay? If you slice through it kind of slanted, right, you get what's called an ellipse. It's basically an oval, okay? You go right through the middle, you get a circle, okay? And then if you go straight kind of down through it, you get what's called a hyperbola. So, it's kind of like two parabolas that are back to back with some space between them, okay? So we're basically going to talk about all of these different shapes and their graphs, which is kind of fun. I know you guys are so excited, but it is pretty cool that it all comes from a cone.
Can we make cones and slice them?
Sure. Have to find some. Maybe not right now, but we can pull out the clay, make a cone and slice it. Yes.
I would like to do that.
Okay, we can do that. All right, so ew, what is that? Yeah. I don't think so. I guess. I don't really know a whole lot about what's happening.
I think we go straight to where
I would ask Miss Trump because she's kind of the one in charge of that. Yeah, I want to say you guys go straight there, but I'm not sure. So, okay. All right, so let's start talking about a parabola. Right, so we've talked about those quite a bit when we've talked about quadratic equations. We talk about them and think about them a little bit differently as a conic section. Yeah, okay, we got that. Sounds crazy, but I think it will help make sense. So it's the set of points in a plane, right, back to our geometry days here, right, that are equidistant Do you remember what that word means?
No.
Can we figure out what that word? Yes. See, you said you had no idea and then just immediately said what it was.
I just put 2 and 2 together.
So from a fixed line, right? So that line is called the directrix. Okay. And a fixed point. Right, and that point is known as the focus point. Okay, so right, so that's kind of what it looks like. You have a focus point, right, and you have the directrix. And so the distance from each point on the parabola to the directrix and each point to the focus point are always going to be the same length. That's what that's saying. Okay, so basically, as long as we know what this point is and we know what this line is, we can pretty well sketch a parabola, is what that definition's telling you. Right, so then they do a whole lot of math, okay, and come up with this formula for a parabola, which is right, so that's like your basic formula. So it's 1 over 4p times x minus h squared plus k, right? So this part of it should look fairly familiar, right? That's just kind of our vertex form of a quadratic equation, of a parabola, right? Right, so P is the focal length. So like P is, again, it's this part for how far the focus point is from the vertex. Okay, and we can usually figure that out fairly easily. Okay, I know this is a lot, but I think once we do it, it will make more sense. Okay. All right, so on that first example on page 397, right, it says to graph y equals negative 1/2 x plus 3 squared plus 2. And it's vertex, focus, and directrix. So we need to make sure we mark that, and that. Okay, so looking at this first, what's our vertex? What numbers tell us that? Vertex is always h and k, right? So it would be negative 3 and 2. Right, because in our original formula, it's x minus h, so you have to do the opposite sign. Okay, so again, our original formula was okay, so h and k give you the vertex, right? okay, is typically A, right? Like if I write it like this, is that familiar?
Yeah.
Yeah, right. So normally A is that number there, right? And so in this equation, it's 1 over 4p, right? We got to figure out what p is, okay? So if you kind of rearrange that, basically, p is always going to be 1 over 4 times a, right? So to find that, you just do 1 over 4 times whatever number you have in front of your parentheses, okay? Right, so in this case, it's 1 over 4 times negative 1/2. So in this case, it would be -2, so negative 1/2. So basically, that means when we graph this, let me put a grid on here. Yeah. Okay, so fixed my vertex, right? Focus point, since p is negative 1/2, I went from my vertex down halfway, right? So I went down because it's negative 1/2, right? And then, oh, they're making this way harder than it has to be. Okay, so then that directrix line is going to be that same distance away, just on the other side. So it's going to be at 1/2 up there, right? Are they just plugging in numbers? Graph their prolab. To find kind of how far out from the focus point you go to like make the shape of your parabola, right? Does that make sense? Kind of. You're going to take, not the ruler, right? You're going to take absolute value of 4p. So in this case, that would be 2, right? So basically, and then you're going to go like, so a line of 2 total and go here, right? So then that is enough to give you the shape of your parabola. We're going to walk through this again. I know I lost a lot of people. One each way. So 2 is the total length of the line. So half, you want to find that and then half it. Yeah, like half on each side. Right. So then that means this line here has a total length of 2. Yeah, so that's called your focal width. Oh, there it is. Right, so again, that's what it gives you that shape of the parabola. Okay. That was a lot. Let's talk through it. Okay. So this is your standard equation, okay? To find the vertex, you just look at these 2 points, right? Opposite sign of whatever's in the parentheses always. So if it was like -3, we would have had a positive 3. But since it was +3, we've got -3 and 2, okay? To find the focus point, right, and technically the directrix line, right, you have to find what P is, okay? So you're going to take 1 over 4 times whatever number you have in front here, okay? So if there's nothing there, it would just be 1, right? So it would just be 1 over 4, okay? This case, we got 1 over -2. So that told me that from my vertex, I'm going to go down 1/2. Okay, if it was positive, I would have gone up 1/2 and my parabola would be opening upward. Okay, it's going to always open towards your focus point, right? Focus point's always inside the parabola. Okay, that directrix line is always that same distance back the other way. Okay, so it's opposite. Then to figure out how wide to make my parabola, okay, I do 4 times p, right? So I get 2. Right, absolute value of it because it doesn't really matter. So that means that the width at my focus point is a total of 2. So I kind of do half and half. So I went 1 on one side, 1 on the other. And that's enough just to give you that width to kind of get the general shape of your parabola. Okay. Did that help? A little bit. A little bit? Okay. Let's do another one. I just want to do kind of a normal one, but it'll be all right. Okay, so this next example says to like write the equation. I'm not super worried about that yet. We'll worry about that tomorrow. So I'm just going to jump to the part where they give you the equation. Okay, so this one, yes, it's going to say x equals.
Wait, what is this one?
So we're going to graph another one, basically. But our x and y are swapped, right? Any thoughts about what that means? What's that going to do to our parabola?
Flipped.
It's going to be sideways.
Sideways.
Yep. All right, so actually, I don't want to do a sideways one yet. Let's get the normal ones done first.
Either.
Abby's just like, no, thank you. All right. Let's. Oh, I don't want graphic calculators. Let's additional ones. Okay. Let's do this one. Okay, so what's our vertex?
It's a -3 and then 1.
-1. Yes. Okay, so then our next step is to find p, right? So it's 1 over 4 times 1/8. So that would be 1 over 1/2, right? Which is then 2. Is that what you were going for?
Yeah. That's what I was going for.
All right. Okay, so then we plot the vertex. The recording part back on for the graph. All right, so again, plotted the vertex, right? Found that P was 2, so we went up 2 to put our focus, down 2 to draw that directrix line. Right, and then the focal length is 8, so we went 4 this way and 4 this way to get the shape of the parabola. All right, was that better? Yes? Okay. I also don't want to do too much with so many people out.
How about you just give it to tomorrow?
Oh, yeah, we still got some more stuff to learn. You guys aren't going to be here tomorrow.
Well, Wednesday.
Yeah, I think, honestly, though, this puts us at a good stopping point. Actually,
Oh.
all right, hey, calm down. Let's, how about you guys just sit and we'll try one on your, I'll put one on the board, you can try it on your own. See, I feel like that's,
Dill pickle.
all right, okay, so let's try this one. Okay, so try that one. All right, so our vertex is 5, 3. So then the focal length. So should be something like that. Yep.
Uh-oh, mine's on the wrong side.
Oh, no, mine's on the wrong side. All right. We're going to do some magic. Ready?
Wait, so it is supposed to be on the wrong
Yeah, it is. I even know that. And
Hey, then I was supposed to be right.
one chance.
It was 1 minute late. Now it's 1 minute early now.
It is? That's
Probably because they had to adjust it with the time change. I agree. All right, it's actually over there. Keeping you on your toes.
Well, I had it over there and then I thought that I was wrong, so then I
No,
moved
it's
it
not
on.
an extra. It's not an extra.
I'm sorry. All right, guys, have a good day. I guess I'll see you Wednesday.